stopped here, right? How we can do the radix sort? With the help of number of digits, right? Remember that radix sort? Based on the number of digits, we are going to we are going to perform the radix sorting algorithm. Okay. There are initially the div equal to 1 and pass equal to 1. How many passes you have to do here? Based on the number of digits. Okay. Particular element may have 2, 3, 4, any number of digits, right? It having 3 digits, then we should have 3 passes. Okay. And while this loop is executing until what pass less than or equal to node is the number of digit. Okay, loop is 1 to key size. Already the I have explained key size is nothing but for a number 0 to 9, for alphabetical 0 to 25, for element 1 to n. This is nothing but number of elements in the particular list. Bucket number, we are going to find out the bucket number. For the radix set, we have the bucket number is 0 to 9. Here we are going to find out the bucket number. How we can find out? Array of element, this is the original element, and divide by div here is now the div is 1 and mod 10. Okay, from that we have to find the bucket number based on the unit value, so that that's why the div value is 1. Okay, then once the bucket number is found, then we have to append the particular element into the particular bucket. Okay, array element is inserted into the bucket number. What bucket number here? The previous line we have to find out the bucket number. So bucket of 0 or bucket of 1 up to bucket of 9, we have to insert the element array of element. Okay, again once the process is completed, all the elements are inserted into the bucket, then we have to do what? You have to need to arrange in array of combining all the elements in the bucket. Okay, you have to combine all the buckets. Okay, this is the process, and once it's done, we have to increment the value by 10. That means now we are going to see the concentrate on the 10th position. Unit place is over. After that, we have to go with the 10th position. Okay, 10th place. Then once 10th place is over, then we have to again multiply with 10. That is 100. Okay, now the div value is 1 and 1 into 10 is 10. So here the div is changed to replace by 10. Okay, so again the next process 10 into 10, that is 100. Okay, like that it goes. Okay, this is the radix chart. Okay, yesterday I left this. It's a program for radix chart. Time complexity for the radix is depend on 3 elements. One is d is the number of digits. Okay, based on the digits only we are going to process. I mean 4 digits means we have to pass, we have to we have to process up to pass 5. Okay, so like that it depends on the number of digits and number of elements and range of keys. Okay, it is a numerical, then 0 to 9. It is an alphabetical, then we have to go with 0 to 25. Okay, okay, now we are going to see about the concept what hashing. Have you heard about hashing anywhere? Yes, students, have you heard hashing? What is meant by hashing? What is meant by hashing? Anyone? Hey, students, are you there? Respond me. What is meant by hashing? Have you know about that? Hello, students, are you there? Do you know hashing or not? No. Okay, okay. Okay, pa. Hashing is a technique that is used to store, retrieve, and find data in the data structure called hash table. A hash table is nothing but is one of the data structure which is used to store the elements, and here the data are arranged in some manner so that we can easily retrieve the data based on the keys. Okay, this one. This is called hashing. Hashing is one of the technique which is used in the data structure, which is for why it is storing the elements in some order so that we can easily retrieve the data. Okay. It involves two important concepts, that is hash table and hash function. Here the data are arranged in the form of table. Okay, and how we can store the data into the table means with the help of hashing function. We are going to perform one function. Based on that, we are going to insert the element into the particular table. Okay, we'll see how we can insert the element. So hash table is a data structure that is used to store and retrieve data very quickly. Okay, it is an array of some fixed size containing the keys. It is an array of some fixed size we have to fix for the particular table. Okay, we can mention the size for the particular table containing the keys. The particular table contain the keys, and hash table run from 0 to table size minus 1. Okay, for the array we have to store the elements from 0, right? Like that, here also we are going to insert the element or store the element from 0 up to table size minus 1. For example, the table size is 10 means we can insert the elements from 0 to 9. Okay, the position 0 to 9, and each key is mapped into some number in the range 0 to table size minus 1. That means we are going to insert the key into the table, right? So for that we are going to perform one function. That function returns one value, that is a numerical value, that may be from 0 to 9. I mean, depends on the table size. Okay, the mapping function return the value, it depends on the table size. Based on that we can insert the element. Okay, this mapping is called the hash function. Insertion of a data in the hash table is based on the key value obtained from the hash function. Okay, uh, in that hash function we get one value. Based on that value only we are going to insert the data into the table. Using same hash key value, the data can be retrieved from the hash table by few or more hash key comparison. Okay, more than one key we can compare, and if, I mean, for example, if I'm having I know about the address A, so that I can go with B also, right? With the help of A, the next element is B, so B, so I can go with B also. Like that we can compare and fetch the data. This is called hashing. Okay, why we are using means, for example, we have a list of elements. Okay, in the list of element we have to store in one place, that is hash table. We are going to store the elements in particular table. But if we want to pick one element from the table means, how we can get the data? We have to search, right? From the initial position itself, search, linear search, binary search, everything we have studied, right? So we can pick any one of the option and go with the searching, right? But here what is happening, no need to go with the searching. Just the key is for the data is inserted, right? Data is inserted into the hash table. How means, with the help of one function. One function is performed. Based on the function we just insert the value, so we can easily get the data from the key. Okay, from the position. Okay, for example, in 0th position the data 9 is inserted. In this in 4th position data 10 is inserted. Like that we can have prior information, so that we can, with the help of the key, we can directly go to the table and directly pick the particular data. No need to go with all the searches. Okay, this is the concept of hashing. Hash function, how we can do the hash function. With the help of this only, we can insert the data into the table. So we'll see how we can go with the hash function. This is a function which distributes the keys evenly among the cells in that hash table. Okay, it is one of the function which distributes, which distributes the keys evenly, just storing the data, storing the elements in the hash table evenly. Okay, with the help of this function. Using the same hash function, we can retrieve data from the hash table. With the help of the same function, we can retrieve the data. Hash function here, the hash function, with the help of the hash function, we can insert the data and we can retrieve the data. Okay, and the hash function is used to implement this particular hash table. The integer value returned by the hash function is called hash key. Okay, one value is returned by the particular function, that is called hash key. If the input keys are integer, the commonly used hash function is this one. This is the formula for finding the hash key. Okay, this is nothing but hash key. Okay, hash key. We have to find the hash key. Based on that only we can insert the elements into the table. For that, formula is key module operation table size. For example, I'm going to, my table size is 10. Okay, assume my table size is 10. Okay, my key is 18. Okay, my key means nothing but element. The element I'm going to insert. Okay, that element is 18. For that 18, I have to find the hash function. Output of hash function is what? One integer, right? So based on the integer, I can insert the element into the table. Okay, so h of 18. Okay, h of 18, how we can find? Key is nothing but the element I'm going to insert, right? So 18 module operation mod 10. What's the answer? What is the answer? 8 mod 10. This is the answer. Are you sleeping, all of you? Yes, 8. Please respond quickly. The answer for this is 8. So I can insert the particular element 18 into the 8th position. Okay. 8th position means my table size is 10. So I can insert from 0 to 9. Okay. My table size is 10. So I can insert the element from 0 to 9th position. Here we have to find the hash key. Okay. For the particular element. So the hash key for that element is 8. So I can insert the element 18 into the position 8, index 8. Okay, here I can insert the particular element. Okay, is it clear everyone what is meant by hashing and hash function? How we can find the hash key? Yes, is it clear everyone? Are you following? All of you, respond me. Is Yashvin, Abhishek, Ramya, Manoj, Ismiha, Sandeep, Santosh, Praveen, Sujita, Pavitra, yes, Sanjay, Ritika, Mohit, Rajalakshmi, Narasimha. Sakti Charan is also there, is very good. Responded. Good. Yes, Rubaina, Sharon, Nitish, Jashwant. Okay. Okay, fine. Now the value is find out, the key is find out, and in this position I can insert the element. Okay, we will see how we can. Here I'm having list of elements. This is the table with a size of 8. So I can insert 0 to 7. Okay, this is my position. I'm having the elements of 36, 18, 72, 43 and 6. Okay, these are the elements in my list. So I am going to find out the hash key for that element. How we can find? Formula for hash key finding is what? H of key equal to key module table size. Okay, right? Is it so? This is the formula for finding the hash key. Now I'm going to find out for 36. So what is the formula? Key module operate particular table size mod. Key mod table size. Key is nothing but 36. Mod is not mod operator and table size is 8. So what is the answer? 36 mod 8. What is the answer? We know, right, how we can perform the modulo operation. Is all of you any doubt on module operation? We know the difference between the division and module operation, right? If you are using the module operation, then we can get what value? Remainder value, not a quotient. Yes. So the key is 4. So I can insert the particular element 36 into the fourth position here. Okay. This is the way we can insert the element into the hash table. 18 model 18 mod 8. What is the answer? That is 2. 2 8s are 16. So remainder is 2. So the value is 2. So I can insert the particular 18 into the position 2. Okay. And third one 72 is the remainder is 0. So I can insert the 0th position. And the fourth element is 43. The remainder is 3. So I can insert here. And for the element 6, for element 6 mod 8 means what is the answer? 6 only, not a 0, not a 1. That is the next concept, Ramya. If two keys are same means we can consider that as a collision. For that we have to do some operation to avoid the collision, and we can make the another position. We can find the another position to insert the particular second element. Okay, we will see in the next slides. Okay, so this is the concept. This is the hash table. This is the hash function. With the help of this hash function, we can insert the element. Okay, the next concept. The next one is collision. Collision is nothing but if two elements are pointing to one position, then what is the process? Okay. For example, here 5 elements are there. Then we have 3 empty places. Okay, 3 empty places. If in another 3 elements we can insert, but that element may be pointing to the same position. For example, 0th position we have already one element. If we want to insert another one element that also give the same value as 0 means, then what is the process? That is called collision. Okay, for that collision we have some techniques to avoid the collision, or to insert the element which can occur the collision. Okay, if two more keys hashes to the same index, the corresponding records cannot be stored in the same location. This condition is known as collision. Okay, the same example here, and add the keys 10, 5 and 15 to the previous table here. Okay, to find, please all of you find what is the position of 10 in this table. Position of 10. Find the key value for the 10. Hash key value for the element 10. Please tell me. Ten mod 8 mean 2, right? So for that element 10, I can insert at the where position 2. Okay, in this position. But here already element 18 is there. So for that we need some procedure to overcome this problem. Okay, for the element 10, the value is 2. So already 2 is filled with 18. And for element 5, I'm going to insert another one, element 5. For this 5, the hash value is, hash key is 5. So there is no element in the 5. So I can insert here. And for that 15, the hash key value is 7. So I can insert 15 here. The only one collision occur in the position 2. Okay. 18 and 10. Both are pointing to the same position. Then what is the process? Okay. This is the, if collision occurs, it should be handled or overcome by applying some technique. Such technique is called CRT. CRT is nothing but collision resolution strategies. Okay. Or techniques. There are a number of collision resolution techniques, but the most popular are separate chaining and open addressing. Okay. This is called open hashing and close hashing. Uh, don't confuse. If in the case of here open is coming, then another method only having the open name. Okay, it is opposite to each other. Separate. Otherwise, you can go with only one. Separate chaining and open addressing. Okay, there are two techniques that are very important. Both are what? Separate chaining and open addressing. In the case of open addressing, we have three more techniques: linear probing, quadratic probing, and double hashing. These are the three techniques we are going to discuss under open addressing. Okay. Before that, we need to know about the hashing, right? Characteristics of good hashing function. Okay, one hashing function is said to be good. Then, what is the property of that? Okay, it should be simple to compute. It should be simple to compute, and number of collisions should be less while placing record in the hash table. We know what is meant by collision, right? The collision should be less, and hash function with no collision is a perfect hash function. Okay. Any hash function with no collision means, then we can call particular function as a perfect hash function. And hash function should produce keys which are distributed uniformly in hash table. Okay. The hash function we are for what purpose we are using? To fill the data into the hash table. If it is a good hash function means it should distribute the data uniformly in the hash table. Okay, these are the characteristics of hashing function. Okay, then we will see the technique one by one. Why we are seeing this technique means, if collision occurs, we have to overcome that particular collision. For that, we are using these are the techniques. First one, separate chaining. Okay, separate chaining. This is like our singly linked list. Okay, is any idea now how we can go with us with that particular collision? We are in this separate chaining, we are just implement our singly linked list. Okay, then you people think and tell me how we can implement the collision. Any idea? Hey students, separate chaining concept, we are just implement our linked list. No idea? Anyone? How we can avoid that particular collision with the help of linked list? Yes. Quick response, please. Anyhow, respond me. No, you have any idea or no? No problem. Please respond me. Is anyone in the meet? Respond me. I'm going to avoid the particular collision with the help of linked list. Then how we can? Any idea? I'm audible? Yes. Then tell me. Do you have any idea? Shall I skip this topic? You please refer and study. Respond me, otherwise I will go with that way. No idea, right? சரி இப்போ நீங்களே படிச்சுக்கோங்க hashing, right? All are sleeping. No. Then respond me, ma. Have you no idea means mom no idea, like that you can say, right? Yes, that's what I'm expecting you. Okay. If collision means two elements, more than one elements pointing to one position, right? So how we can achieve with the help of singly linked list? We can make a linked list and place one element, and linked list means we have two fields, right? One is data and another one is pointer field. So in that data field, I can insert one element and I can go with the particular pointers pointing to another node and insert another one element. Okay. Like this way I can insert. This is called separate chaining. Okay. Implemented using singly linked list concept. Pointer field is added to each record. When collision occurs, a separate chain is maintained for colliding data element inserted in front of the list. Okay. The same formula this way. Okay. The two elements are pointing to the position 2. So how I can manage? I can make a list, linked list, okay, and put one element, and pointer is pointing to another one node and insert another one element. Okay, this is the way. If only one element means then no problem. The null point, the pointer field is null. Okay, this is the way we can insert. Please, all of you go with this example with separate chaining in and give our answer. Insert the following four keys 22, 84, 35, 62 into a hash table of size 10 using separate chaining. Go fast. The table size is 10. Okay. Then how we can calculate the hash key for that these elements, and how we can insert the element into the table. Once you done, update me. Are you doing? All of you? Yes. Okay, ma'am. What about others? Are you doing? Yes, Ramya. Any doubt? Ask me. Okay, ma'am. Some people always responding for me. Sakti Charan, are you there? Not in meet. Went out. All of you, please try to complete the mini project and assignment by today. Otherwise, I will mark zero for you. And skill rack programs also very very important. Please, all of you try to complete up to part 11 and try to write the aim algorithm for program up to part 11. Okay, I will show one record sample record for you. I will share. Okay, Ramya. Is which is 22? Is all of you others? Have you completed? Boys, have you completed? Find the position for these elements. Yes, boys, have you completed? Yes, respond Mipa. Have you completed? Ramya and Mika is completed. Then what about others? Yes, please tell me where we can insert the element 22. Which position? 6. And 84 for 84. 35. 62. Okay, what about others? Others, please check with your answer or you got this same answer. Yes, Miga, have you got this? Yes. Okay. What about boys? Respond, Mipa. Need to complete the portion. Do fast. Santosh, Yashvin, is Sanjay, Sandeep. What about you? Okay, Manoj. Abhishek, Nitish, completed. All of you. Okay, okay, Santosh. Okay, okay, okay. The answer is for is Ramya. You said 6. How?
Ma'am, before you showed the slide with size 8, ma'am. In this slide, size 10 is there, ma'am.
No more. This example only I given, right? Insert the following elements with a table size of 10. All are got the same answer. Yes. Then your answers. 2, 4 and 5. Okay. 62. Okay, Ramya, no problem. Yes. 22 we can insert in the question 2. What about others? Have we got the correct answer? 22 we can insert to the question 2 and 84 in fourth question, and 35 we can insert in the fifth question, right? Yes. And 62 we can insert in the second question, I mean collision. So we can insert like a linked list. Okay, this is the answer. Please all of you check with your answer. This is the correct answer. And next one, advantage and disadvantage. More number of elements can be inserted using array of linked list. Yes, we can. If collision may occur many times, no problem. We can insert by with the help of linked list. Okay. And what's the disadvantage? This is for advantage and disadvantage of separate chaining. Okay. And disadvantage, if it requires more pointers, which occupies more memory space. Search takes time. Since it takes time to evaluate the hash function, this is one it taking some time, and also travel the list also taking some time. So it takes more time to search a element. This is the disadvantage and advantage of separate chaining. Okay. Next one, open addressing. The next technique is open addressing. In this, we are going to see about three techniques. One is linear. Yes, is it so? My voice is breaking. Now it's clear. Okay. So in open addressing, we are going to see three techniques. One is linear and quadratic, and the third one, double hashing. Okay. We will see one by one. This is called closed hashing. Okay. And collision resolution technique. It is one of the collision resolution technique. And we can use the formula as like this. Okay. In the case of previous one, how we can find the hash value? Hash key mod table size, right? Here also we are going to do the same process, but once the collision occurs, then we use this formula to overcome the collision. Okay. Normally we are going to insert the element with the help of the same formula we have did in the separate chaining. Once the collision occur, then we move with this formula and find the position for the element. Okay. Okay. Here the concept is, once when the collision occurs, alternative cells are tried until empty cells are found. Okay. Once the collision occurs, we have to find the alternative cells until reach the empty cell to insert the particular element. Okay, this is the concept. Open addressing is another one technique for uh, avoid the collision. So here also we are going to use the same formula, hash key equal to key mod table size. Once the collision occur, then we go with this formula. This is nothing but hi of x is nothing but this is the hash key. The key is already defined by, already found by the particular formula, and we are going to add one element, that is f of I. F of I is nothing but plus 0, plus 1, plus 2, plus 3, like that. Okay. Just what is the concept? We are going to find the alternative, otherwise another empty cell to insert a particular element. Okay. This is the concept. We will see with the example. First technique is the linear probing. Easiest method to handle the collision and apply the hash function like a separate chaining. The same formula here we are going to use. and once the collision occur, then we move to this concept, this formula. Okay, this is the sequence. First we need to go with that basic formula, h of key, hash key equal to h of key and mod table size. We have to we here in this way we can get one integer value, right? After that, once the collision occur here, then we go with this formula, that is nothing but h of key plus 1. Here we can say in normal position we can say this is plus 0, right? So we start with same normal basic formula and add plus 1, add plus 2. If here add plus 1, and if the particular cell is empty, then I can insert here. But again here also the collision occur, then I go with the plus 2 and insert the element. If here also the collision occur, then I go with the plus 3. Okay, h key is nothing but the element we get from this formula. Okay, with that numerical value we are going to insert 1, 2, 3 like that. Okay, is it clear? So now I'm going to insert the element 18, 8, 49, 58, 16 into the table size of 10. All of you please work out and tell me where I can insert the element 89. Please go first. Where I can insert the element 89 in the ninth position. Okay, very good. So I can insert the element in the ninth position here. Okay, like this. And for 18, I can insert in the 8th position. Okay, very good. For 49, again you go with the same formula, 49 mod 10. So answer is 9. Already we have one element in the ninth position, that is 89 already inserted in the ninth position. Again the 49 also need to have the same position, need to insert into the particular position. So what is mean by that? This is called collision. So for that we have another one technique, that is linear, with the help of linear probing we can go with the what linear insertion or linear addition. Okay, we just adding one to the particular element. This is called h of key. Okay, normal formula here we can say h1 of key. Okay, h1 of 49 equal to h of 49 plus 1. What is the h of 49? Already we have worked out here. That is the value is 9. H of 49 is the hash value for the element 49. So 9 plus 1 mod 10. So 10 mod 10. So value is 0. I can insert the 49 in the 0th position. Is it clear, everyone? This is called linear probing. When the collision occurs, in the case of step right chaining, we did what? Just we make the linked list and insert the element. But in the case of open addressing, in the case of open addressing, we have three more techniques. One is linear, quadratic, and double hashing. In the case of linear, we just insert the element one by one. I mean linear order, plus 1, plus 2, plus 3. Likewise, we can insert and find the empty position, empty cell, and we can insert the element. Okay. Now the 0th position, we need to check with the 0th position. Already we inserted only the 9th position and 8th position. So 0 is empty. So I can insert the 49 in the 0th position. Okay. Okay, please, what is the value for 58? 8. Okay. Again, here also the collision occur, right? 8 for the position 8 already have one element, that is 18. Now, here also we found out that 58 also having the position of 8. Okay, so how we can avoid? Yes, how we can avoid? Is I'm audible, students? Okay, fine. I got disconnected. Where I stop? Is where I stop? Where I stopped? Pa? H1 of 49. Santosh asked one question, right? Okay. Yes. I have explained the concept, Santosh. Have you heard that or disconnected? Yes, Santosh. I have explained the answer for your question. Okay. Okay. Okay, my if Santosh asking that if zeroth question is not empty, then what is the next step? Yes, we have to calculate again the same formula that H2 of 49. The formula for that is this one. This is the normal formula. H of key equal to key mod table size. H1 of x, nothing but the value is nothing but h of key. The value we find, we get from this formula, the previous formula. This is h of key plus fi of fi is nothing but it just is a linear sequence, that is 1, 2, 3 like that. Okay. So and finally 9 plus, for example, the key is 9 means 9 plus 1 and mod table size. Okay, f of I is the I it may be from 0 to and no end. We can go with 0 to some position. Okay. So here now the collision occurs. So we have to calculate the h1 of 14 and h1 of key. How we can calculate? With the help of h of key. Okay, h of key is nothing but 9 plus 1 mod 10. So the value is 0. If it is an empty, then no problem, we can insert. Otherwise, we have to go with another one step, that is h2 of 49. How we can do the h2 of 49? 9 plus 2. Okay, no difference. Just use the same formula, but the linear sequence only change. That is, this one is changed to 2 and finding the next value. Okay, like that it goes on. Now the 0 is empty, so I can insert. Okay, here 9 and 8 only insert the 0. Again the value is 0, so I can insert the 49 in the 0th position, and we are going to find the next element, that is h of 58. What is the value? H of 58? 8, right? H3 of 58, 1. Yes. H of 58 is 8. 8 already. The 8 position 8 is having already one element, that is 18. So I need to calculate the H1 of 58. What is the value of H1 of 58? Is H1 of 58. H of 58 is 8. Next H1 of 58 is what? 9. 9 also already inserted. The element is inserted. So H2 of 58. What is the H2 value for the 58? 0. Okay. Others able to follow? H2 of 58 is 0. 0 is also already occupied. So we will go with the H3. What is the value of H3? 1. So I can insert here. Okay. This is the way we can go with the linear probing. H of 58. How we can calculate 58 mod 10, that is 8. 8 already having one element. So we have to calculate the H1 of 58. H1 of 58 is nothing but we have to take this numerical value. I mean output of the previous formula, that is 8 plus 1 mod 10. Okay. So this is the value. 9 also already inserted. So go with the H2 of 58. Just changing the one by 2. Okay, the 2 is insert, 2 is added, and again finding the again collision. So go with the H3 of 58. Here 3. Okay, until we reach the empty cell, we can go. Okay, this is the next element 69. What is the H value for 69? 9. So same procedure again. 9 already having collision, having element, so we have to find the H1 of 69. What is the H1 of 69? H1 of 69. 0. 0 also having already occupied. So find H2 of 69. What is the H2 of 69? 1. 1 also inserted, right? So again go with another one, H3, that is 2. So in the position 2 only I can insert. Okay. So here we can insert like this. Is it clear? This is called linear probing. Okay. And the next technique, make a note of this problem and try to find. Okay. We are moved to the next topic. Try to do this is like a homework. Okay. Have you noted? Okay. Next one, quadratic probing. What is my quadratic equation? We have studied in maths, right? What is the meaning? Anyone? Quadratic meaning degree of 2. Okay, that is exponent 1 squared or I squared. We can say here I squared. In the case of linear, what is the value of f of I? This is I. But in the quadratic, this is I squared. Okay, this is the different. Okay. Sorry. So to resolve the primary clustering problem, quadratic probing can be used. With quadratic probing, rather than always moving one spot, we move to the I squared spot. Okay, from the point of collision, where I is the number of attempt to resolve the collision. Okay, is it clear? I 1 squared, 2 squared, 3 squared. Here we just added 1, 2, 3, right? To finding the position. Here just added 1. Here added 2 and 3. But in the case of quadratic, we have to add 1 squared. 1 squared is nothing but 1. 2 squared again here. 2 squared is nothing but what? 4. So I can add 4 to the particular key value and find the position. And here 3 squared. Like that we can go and find the position. This is called quadratic probing. No difference. Okay. The same thing, but this is one is the I squared. Here, please check 18, 89, 21, 58 and 68. So 18 where I can insert. The table size is here 0 to 9. So the table size is 10. What's the value here for this 18? What is the hash value? 8. So I can insert here. Okay. For 89, I can insert the hash value for 89 is 9. So I can insert here. So what's the hash value for 21? 1. So I can insert here. Okay. Now I'm going to move to the another one element, that is 58. So what is the value for hash value for 58? What is the hash value? Yes, 8. But the position 8 is already occupied. Okay. So what is the next step? I have to calculate the H1 of 58. Okay. H of 58 is nothing but 8. Particular 8 is already filled. So I need to go with H1 of 58 with the concept of quadratic probing. Okay. H1 of 58. Okay. How we can find? Here. I is 0 is nothing but this is the same formula. I mean basic formula. The key mod 10. The same formula. So you please skip this and you go with the for 8 is already having elements, so it is a collision. So we need to go with I equal to 1. I equal to 1 means what is that? H of key plus I squared. So 1 squared is nothing but again 1. So 8 plus 1 9 mod 10. So 9 9 also already having elements. So I just I equal to 2. I equal to 2 means what? H2 of 58. I'm going to calculate H1 of 58 also having collision. So I'm going to calculate the H2. Okay, H2 of 58. How can I do? With the help of hash value 8 plus 2 square. 2 square is nothing but 4. So 8 plus 4 12. 12 mod 10 equal to 2. 2 is empty here. So I can insert the 58 into the second position. Is it clear, everyone? This is called quadratic propping. Like that we can move. Here 68. We need to find the hash value. If it is empty, so no problem. We can insert yes. What is that? 8. 8 already have filled. Okay. So we need to find the formula for I equal to 1. 9 already inserted. I equal to 2. 2 also inserted, so I go with the 3. 8 plus 9, that is 7. So in this position I can insert. Okay. Okay, let's another one example. Please note this. Insert keys 89, 18, 49, 58, 68, 78 with a hash table with a size of 10 using quadratic propping. Okay. Please note this and try. Okay, another one topic is the double hashing, rehashing and extensible. Okay, that's it over. This is a simple topic only. I can complete within 15 minutes. Tomorrow we are having lab as right. In that time I will complete the portion and so the portion for lab also. Okay. Today only I can give the time for submitting the what assignment and many project. All of you please try to submit. Otherwise I can't able to give marks for you. Okay. Please consider this. Try to complete the mini projects and assignment and so the skill rack program. Okay. Tomorrow we have lab. I will check. Don't say any reason. Please all of you try to complete up to part 11. I will expect all of you guys. Please try to complete. Now we are at the end of the semester, right? Make effort, give some effort to the works and complete the course in better way. Okay. Any doubt? And so please start to write the record work also. You know already about the record work, right? You may write in the same one also for C language and okay, C language. So please, if you have any doubt, please ask me. Otherwise, you please start right with aim and algorithm. Once the solution is opened, then you can take the printout. When should means is Sandeep, I will send the sample record, no problem. But Santosh, exactly, I don't know the time. Please, as soon as possible, you can complete. Okay, don't wait for the time after exam, madam. Which exam, pa? Semester. Oh, okay. I don't know clearly, but it may be after the theory. I think so. So, if I come to know about that date or timing respect to the lab, I will give you the information. Uh,
Sumita ma'am, it's only after theory exam ma'am.
okay, ma'am. Is Santosh after the theory only? No problem. All of you, even though you can, if you're ready with it, then it is easy, right? Start write the record work. Don't wait for the last minute. that is not good. Okay, once you find the time, please try to start your work, and if it is completed before the exam, no, then no problem, we will be I'll be happy also. Okay, all of you try to complete the mini project assignment and skill track. Don't forget, tomorrow I'm having the labas. I will check all those things and mark mark them, mark all of you those who are not completed. Okay, thank you, students. We will see in the next class tomorrow. Yes, yes. Thank you, all of you. Ma'am.
Yes, ma'am.
Okay.